Alright, this is chapter 4, section 2, and we're doing example 15. So example 15 is unlike the ones that we've seen before. This time we are looking to get payments within a specific year and how much interest we paid in a specific year. So first let's read the problem set for timeline and then we'll take it from there. So an $80,000 home loan, so that means $80,000 goes over here. Is obtained for 20 years at 6% compounded monthly. And the first payment was made on May 10th, 1999, so 5/10/99. How much is paid in the year 2005? Oh, sorry, first payment's here. This would be 4. This first payment paid would be there. So then the next payment would be 6/10/99. Okay. So first thing we have to do here is we need to figure out our monthly payment. So our I is going to be 0.06 over 12. And then we're going to find our regular payment, so it's going to be 80,000 times, and I'm just using the A sub n formula here. And then our n for total payments is going to be 12 times a year for 20 years, so 240. So when you plug that in your calculator, that means our monthly payment is going to be $573.15, because this is the same setup as the previous problem we were doing in example 14. Only difference is here we have dates. Okay, and again we're looking for a specific year. Alright, so now we need to figure out the last payment, how much we owe after the last payment. So owed on loan after last payment in 2024, because again we're doing 2025, so that means this would be December 10th 2024, because we're doing full months, so we're going to go to the next day of the month. And then we're also going to need to figure out how much is owed on the loan after the last payment in 2025, or sorry, in 2005. So that would be December 10th, 2005. Okay, then after we take those two pieces, we're going to find the difference, and the difference in this one and this one is going to give us the total principal paid. Okay, so I'm going to call this one X, and I'll call this one Y, so this would be X minus Y. Okay, right here. And then we're going to take the number of payments we make in 2005, which would be 12, times our regularly scheduled payment, which would be $573.15, minus that difference, so we're going to call this difference Z. Okay, so then we can set it up and just keep going. So now we have to count how many payments we did to get to here. Okay, so first payment is, so we have May, and then we're really doing December's. Okay, so we May and December. Then we have 99, 2000, 2001, 2002, 2003, 2004, 2005. Okay, so I'm just going to make a little table here just to help me sort it out. Okay, so May was our first payment, so I'm going to write down my months here. So January, February, March, April, May, June, July, August, September, October, November. So we're in May, so this payment 1. So June would be payment 2, July 3, August 4, September 5, October 6, November 7, then December would be number 8. Okay, now once we have that piece that we're going to do number 8, what we're going to do is we're just going to add 12 to get to the next full year, because we're going to do 12 in 2000, 12 in 2001, 12 in 2002, 12 in 2003, and 12 in 2004. So I'm just going to pull up my calculator here to help me calculate that, because I don't want all my numbers to be off because I'm having trouble counting. So 8 plus 12, 20. And we add 12 again, 32. Add 12 again, 44. Add 12 again, 56. Now we get to the one we want, add 12 again, 68. And you could do the same thing, just add 12 to the May ones and then count down from here. You get the same answer. Okay, so that means right here N is 68 because we've made 68 payments so far. Right? Now if we go another full year to get all of those ones from 2005, we'd be at 80. Okay, so that means here our N is going to be 80. So now we're going to use 80,000 taken forward 68 periods. With that interest rate of 0.06 over 12, and subtract that from the payments made so far. Remember, this is SN right here. Okay, here they're going to match, so it's that 4.1 formula, because we're just trying to find what we owe so far. So then for X, we're going to get 80,000 times 1 plus 0.06 over 12. So the 68 minus 573.15 times. So this is my beginning of my numerator. Here's my 1 plus. So that means we still owe $66,017.87, rounding up to that nearest penny. And then we do the same thing. It's going to be the same formula, so you can just do second entry and then just change your exponent. So make sure you change the one on 80 and the one in your S sub n problem to get our Y. So that would be 80,000 times 1 plus 0.06 over 12 to the 80 minus 573.15 times 1 plus 0.06 over 12 to the 80 minus 1 all over 0.06 over 12. That's what I just entered. And when we did that, we got $63,019.58, rounding to the nearest penny. So I'm going to take those and subtract. So we subtract the bigger from the smaller, so it's going to be X minus Y. Okay, so 66,107.87 minus 60,019.58. So that means that the principal paid so far in this year is $2,998.29 is your principal paid. So then we've put in 12 times 573.15, because that's all the payments that we made in that year. So that's $6,877.80 minus the principal that we paid. So again, this is total payments. Total paid in 2005. This is total principal paid in 2005. Okay, that's what this piece is. So we get 6,877.80 minus 2,998.29. So that means interest paid would be $3,879.51. Okay, so now later when we do amortization tables in chapter 5, we're going to use this formula to jump to a payment after we've made so many payments. So we'll just jump, and this would be the same formula we used, just like we did here. We jumped to the end of the 60th payment, and then we jumped to the end of the 80th payment. So the same process.